Hello everyone, Dr. Polaris here. By the Middle Eocene, the first truly large and entirely marine cetaceans had emerged. These were the Basilosaurids, animals that completely severed their ties to the land, and in doing so were the first archaeocetaceans to become true apex predators, feeding on sharks, a variety of fish, and their smaller relatives. They were also the first whales to somewhat resemble their modern relatives, and were indeed close to the common ancestors of the more derived odontocetes and mysticetes. Possessing elongated narrow bodies, powerful jaws, and fluked tails, Basilosaurids did still retain some basal traits inherited from their terrestrial ancestors. The nostrils, although positioned halfway up the snout, were still placed further forward than the blowholes of modern whales. In addition, all members of the group still retained a pair of very small hind limbs. Although possessing little functionality, these rear legs may have been utilised as clasps while mating. As a whole, Basilosaurids were notably larger than their amphibious ancestors, ranging from 4 to potentially 20 metres in length, although some genera, with some very notable exceptions, would have been lighter in build than comparatively sized modern cetaceans. Even the smallest genera were more massive than all earlier archaeocetaceans, with the 5-metre-long Dorodon weighing between 1 and 2 tons. First originating roughly 43 million years ago, Basilosaurids are also the first marine mammals to possess a truly global range, with fossil remains having been recovered from all continents including Antarctica, although they almost certainly first evolved in and around the Tethys region. It is thought that Basilosaurids were most at home in shallow coastal environments, largely avoiding deeper waters, and would have been able to prey on almost all other marine or amphibious animals. This was especially true of the most famous member of the family, Basilosaurus itself. This oddly named genus, so called because its early 19th century discoverers initially thought that it was a massive marine reptile, was one of the first macro-predatory cetaceans, and filled an ecological niche that had been vacant since the extinction of the mosasaurs at the end of the Cretaceous. Measuring up to 17 metres or about 57 feet long, Basilosaurus would have been one of the largest animals on Earth during the Late Eocene. Although comparable in length to a 40-ton modern humpback whale, it is theorised that the animal would have weighed in at a svelte 6.5 tons due to its anguiform body shape. Older reconstructions often depicted this genus as a flexible serpentine predator, although more recent studies suggest that Basilosaurus would have appeared more similar to modern odontocetes, albeit with a relatively longer body. The structure of the spine and vertebrae meant that the animal would have been relatively buoyant and would have largely swam in 2 dimensions near the surface. Unlike the smaller Dorodon, Basilosaurus was a poor diver and would not have been capable of sustained swimming as seen in modern odontocetes. Also unlike living cetaceans, the genus retained a functional elbow joint in its forelimbs and possessed heterodont teeth including canines and molars. This would have enabled Basilosaurus to chew, unlike living predatory orcas for example, which swallow their food whole. The cheek teeth were also heavily worn, demonstrating that the animal forcefully grabbed and devoured prey, with the remains of smaller Basilosaurids being found with deep gouges in their bones. Adult individuals have been estimated to have possessed a bite force of up to 20,000 newtons, with the predator aiming for the head of its potential prey before ripping it apart. At present, 2 different species are known, with these being the largely North American B. cetoides and the Eurasian B. isis, which was native to the Tethys region in what is now North Africa and Pakistan. The 2 species varied both in size and diet, with isis being somewhat smaller than cetoides, measuring around 15 metres on average and feeding largely on other cetaceans such as Dorodon, while preserved stomach contents show that cetoides appears to have specialised in hunting large bony fish and sharks. Clearly a successful genus, Basilosaurus was a dominant oceanic predator for about 8 million years during the Late Eocene, only dying out at the very end of the period. Along with other archaeocetaceans, Basilosaurus was probably driven to extinction by a combination of global climatic cooling and resulting changes to oceanic currents. Unable to adapt to these changing conditions, this mighty predator vanished, leaving the seas open for the development of the more derived odontocetes and mysticetes, which rapidly diversified during the Oligocene. Meanwhile, another Eocene Basilosaurid subfamily took a rather different evolutionary path. These were the Pachyceteans, a lineage that possessed pachisclerotic vertebrae and ribs, making them denser and heavier by comparison. This suggests that these whales lived in shallow waters, and these thickened bones acted as a buoyancy control, as seen in modern sirenians. In fact, like modern manatees and dugongs, Pachyceteans are probably slow-moving, heavily built animals that spent much of their time on or near the sandy seafloor looking for food. However, unlike sirenians, these cetaceans were almost certainly carnivorous and fed on benthic fish and crustaceans, possessing a somewhat similar lifestyle to the living grey whale. Until this year, only 2 genera of Pachyceteans had been described, with these being Pachycetus, not to be confused with the similar sounding and far more basal Pachycetus, and the smaller and more gracile Anticetus. These animals range between 6 and 8 metres in length, and inhabited what is now North Africa and the southern United States. However, in the last few months, a new and truly remarkable member of this subfamily has been described, taking the internet by storm. This was the enormous Perucetus colossus, which was without question the largest animal on Earth during the Eocene. This animal is known from 13 vertebrae, 4 ribs, and some parts of the pelvic region. All bones are from the same individual, known as MUSM 3248, and were collected from the Yamaque member of the Late Eocene Paracas Formation in Peru. The specimen displayed a very high degree of pachisclerosis, meaning that its skeleton was incredibly thick and dense when compared to all other cetaceans. The holotype lacks a skull and most of the tail, meaning that producing accurate size estimates for the genus are difficult and fraught with controversy. If compared to its close relatives, the animal may have measured up to 17 or 18 metres long, similar to Basilosaurus cetoides, but was substantially more massive. Initial descriptions of Perucetus indicate that it may have been the heaviest animal to ever live, outranking even the modern blue whale, with estimates ranging from 85 tonnes to a truly astonishing 340 tonnes. However, the latter figure was only treated as a very liberal upper estimate in the paper describing the genus, and should not be taken as gospel, as it has been in a whole host of popular science articles. After the media circus died down a bit, paleontologists have suggested that the mean mass of 180 tonnes is too high, with comparisons with its much smaller close relatives revealing an average weight lying somewhere between 66 and 85 tonnes. Even though this would make Perucetus smaller than the blue whale, these figures are still extraordinary when placed alongside the 6.5 tonne Basilosaurus, which, as we have seen, was of a comparable length. Not only would this make Perucetus by far the most massive animal on Earth during the late Eocene, it held that title until the evolution of the first truly large baleen whales during the Miocene approximately 15 million years ago. To put the sheer bulk of this basilosaurid into perspective, it would have outweighed large female individuals of Otodus megalodon, which averaged an estimated 61 tonnes, and was comparable to modern North Pacific right whales in weight, which are the second heaviest living species of cetacean. In addition to size estimates, we are also in the dark regarding the potential lifestyle of this giant. Like other basilosaurids, it was probably a carnivore, but given its incredibly heavy bones, it probably dwelt in shallow seas and fed on benthic fish, crustaceans and bivalves. The structure of the vertebrae suggests that Perucetus may have possessed a flattened tail, similar to that of a modern manatee, and swam with slow vertical undulations of the body. It may have also been a scavenger like large demersal sharks, although more complete remains are needed to solve the mystery surrounding this amazing animal. In addition to this, the validity of the family Basilosauridae has sometimes been called into question, with some studies suggesting that its members may have formed a grade leading up to modern cetaceans instead. One potential subfamily, the Dorodontians, have at times been positioned as the most derived basilosaurids. These were generally smaller and more agile animals than their titanic relatives, being better able to dive and swim in 3 dimensions away from the ocean's surface. The type genus was of course Dorodon itself, which measured about 5 metres or 16 feet long and possessed a near global range, with fossil remains being recovered from the Tethys region, the United States, New Zealand, and the Western Sahara. In many respects, it would have resembled a small Basilosaurus, and was once thought to simply be a juvenile of that genus, although young Dorodon individuals have since been described, confirming that this animal was a valid taxon. An accomplished and agile hunter of fish, mollusks, and cephalopods, Dorodon lacked the distinctive melon organ of modern toothed whales, and was therefore incapable of echolocation, utilising vision instead to track prey. Fossil remains of juveniles have been found with unhealed gouges and bite marks which directly match the teeth of Basilosaurus, indicating that Dorodon fell victim to its much larger cousin. Other potential relatives were smaller, such as the recently described Egyptian genus Cetus from the Late Eocene circa 41 million years ago. This lightly built animal is known from an adolescent individual close to adulthood that measured just 2.5 metres or 8 feet 2 inches long, and is estimated to have weighed a mere 400 pounds. This makes Cetus the smallest known basilosaurid, with examinations of its teeth indicating that this genus developed more quickly than modern cetaceans, indicating that basilosaurid young were relatively precocial when compared to dolphins or baleen whales. Analysis of well-preserved skulls of basilosaurids have also revealed that these animals were not as intelligent as living cetaceans, with the brain case being notably smaller in comparison to the body size. Despite this, however, basilosaurids, whether they represent a genuine family or not, were a pretty diverse bunch that displayed adaptations to a wide range of ecological niches. From small agile hunters to surface-dwelling apex predators, these animals thrived during the second half of the Eocene, becoming the first archaeocetaceans to spend their entire lives in the oceans, finally severing the need to return to land to give birth. They were also the first cetaceans to resemble the modern forms that we are familiar with today, albeit with several archaic anatomical features, such as differentiated teeth and the retention of hind limbs. Basilosaurids would become extinct at the end of the Eocene, being victims of an extinction event caused by global cooling that reduced their preferred warm coastal habitats. However, the modern cetacean clade Neoceti directly evolved from animals considered to be basilosaurids, with recent studies suggesting that relatively small members such as Perucetus may have been close to their ancestry. Indeed, the youngest known archaeocetacean, Cecenodon, from the late Oligocene of New Zealand, displays features intermediate between toothed whales and basilosaurids, suggesting what such a common ancestor may have looked like, one that gave rise to the staggering diversity of modern cetaceans. Thanks for watching, everyone. The next episode will be covering the enormous elephant Paleoloxodon, the current heavyweight champion of terrestrial mammals. See you again soon. Cheerio.